into the real stuff now. So doing the work, getting through this DR103. This might take 2 sessions, 2 separate videos to get everything done. But we're going to dive right in. Going to start with removing the shield thing that somebody installed. No idea what that's there for. But we're going to use this big guy, the SPG-80L, the Big Bertha, to do that. So I'm going to plug this guy in, let it warm up. And while that's warming up, let's see. Okay, so while that's warming up, let's talk caps here for a second. Yeah, so for the capacitors, we've got, you can kind of see just from the arrangement here, this is a single, this is a double, single, single. So this must be our 50-50 from the stock, whereas these are 220F. Now, 220Fs were hard to find in a can cap, so and then this guy over here, 16 and 32. We're doing F&Ts for all these. So I've got a 32-32 to replace the 16-32 here. And then for these 220 microfarads, we're going to do 200 microfarads in parallel. Because when we add caps in parallel, when we put caps in parallel, they add together. When they're in series, they divide. So we'll end up with 200 microfarads instead of 220 for these. And then for the double, I do have a 50 microfarad for this guy. Yeah, that should all be close enough to stock that really it would be hard to hear a difference. So we'll start pulling this guy off once my giant soldering iron is heated up. Then we'll do the caps. Then we will probably do the master volume. I'll probably pull anything at that point that I know is wrong and then start working through. I think I probably am going to have to replace these tube sockets. The gunk that's on there appears to be, I tried to clean some of it off on this spot just with isopropyl alcohol. And I think it actually is melted plastic or flux or something from these guys overheating at some point, probably when that original output transformer blew. Yeah, and we'll probably cut this guy up into, I'll cut down this video to a short version and then have the long, like full video available if anybody's interested in that. So I'm not much of a solder wick guy for tight situations. I typically prefer a solder pump, as I've mentioned on this channel before, but for getting those big globs off the chassis, some of this super wick works really good. And you can just heat up the soldering iron and drag it through, especially with the Big Bertha. Now I'm just hitting these with some isopropyl to soak in a little bit. Try to clean up some of that extra flux that was on there, some of those brown spots. So I'm just going to let that soak for a sec and then try to wipe it up or scrape it off. And we'll let our massive soldering iron cool down. Then move on to some caps. Okay, this is cleaned up as much as I need it to be for a personal amp. If this were a customer amp, probably would spend a little more time with that, but this is fine for me. So as I said before, for these 220 microfarad caps, we're going to use 2 100 microfarads in parallel. So I'm going to go ahead before I install these and put a wire across these two nodes to go ahead and put these points in parallel to make this a 200 microfarad cap before doing the install. So I'm just going to go ahead and do that before diving into actually pulling these, and I'll show you what that looks like once I'm done. So just to show you an example of the first one of these. So I've taken this 100 plus 100 microfarad, which normally would be one here and one here, and just taken a piece of, I guess, 22 gauge wire, and then stripped off. I left part of the insulation here so that it wouldn't just totally fall apart as strands, because this is stranded wire, and then wrapped it around each of these nodes, soldered it in place, and then tinned the back. So now when I install this, if I measure from here to here or to here, this is a 200 microfarad cap, and I just have the positive as this whole node that I can connect to either side, and then the negative will be here. So I'm going to trim these wires and then do the other ones and start installing these. So before we replace our first cap here, I think we'll start with this guy over here. I want to show you one thing I'm going to do. So I'm basically going to set this to the continuity mode where it beeps, and I'm just going to verify that this brown wire is in fact the ground. You can see these other two, I get nothing. And since we're replacing this with a 3232, it doesn't really even matter which one of these I connect to which, although now that we know that, we can test for capacitance. Our black probe on the ground, and we can see this guy is, oh yeah, somewhere around 42. Now this cap is bad, so this is not a good measurement, and it's in circuit. And there's 21 or so. So this is probably, the red wire is probably the lower of the two, the 16, whereas this one is the 32. And you can see right there from that reading, right, that we're getting 40 and 21. Caps are usually 20% tolerance. So switching to a 3232, not necessarily a big deal on something like this. Okay, so we're going to loosen this retainer bolt here, and then wiggle this guy out. I'll desolder these wires and then get the new guy in. Just to zoom in here to illustrate a couple points, but we have a nice half wrap on these connections. So there is a mechanical connection on each of these wires, but it's not enough. It's not to the point where it'll be hard for another technician to undo that work in the future the next time this amp is getting a cap job. Nope, losing focus here. Here we go. And then also left the capacitor in place so that the values are face up instead of face down. So if someone opens this up, they can easily see what value is in there. Okay, gonna move on. Gonna just work my way down the line. These guys will be easy enough. Just need to pull the wires in the resistor. Gonna use the original resistors. We'll measure them as I go. This one will be a little trickier since it's buried underneath those diodes. So I'll either pull a couple of these diodes or work it from the bottom, remove the capacitor, and then do the work. I should probably show you how I'm removing these resistors easily, or more easily than I otherwise would. You can see this one hasn't been done. This one's halfway through. So what I'm doing is just applying heat to this node, then pushing the resistor in, heat to this node, push the resistor in, because the legs are hooked around these nodes. And that allows me to then get to that hook, which I can then straighten out with some pliers so that I can apply heat, pull, apply heat, pull. That way we're not, even though we're not going to reuse this cap, we're not going to overheat the wire and the insulation or anything like that. But that's a good method, especially when you're working on PCBs or something like that, where you don't want to overheat things and then end up lifting a trace. Okay, I'm going to go ahead and do the rest of these. So the first two filter caps are in place from this series of 4. And what I'm going to do here, this guy's all ready to be removed, but I'm actually going to weld this as out. You can see there's a jumper wire that goes from this guy to the other one underneath there. This one's going to be a little hard to access for the solder points with the diodes in place here. So I'm going to remove this guy, put the new one in place, get ready to solder. But before I do that, before I connect these wires, I'm also going to, with the wires still connected to this capacitor, remove it and then desolder the wires, solder to the new capacitor, put that one in place, and then install this guy. So really it's kind of a combination for these two just to make it a little easier. So I'll kind of show you what that looks like, but I'm basically going to, with the wire still attached, push this guy through from the other side of the chassis, disconnect, reconnect to the new guy, then push it back up into the chassis so I don't have to try to solder and navigate getting underneath the legs of these. Alternatively, we could remove these diodes and just reinstall them, but I think this will be a little bit easier. Okay, so you can see I've loosened both these remaining guys up, pulled out the one that has no connections on it, and then I've got the old resistor from that one ready to go with our connection to turn this into a 200 microfarad capacitor. Now this guy is still connected. Let's see how much slack we have here. Okay, not a ton, but probably enough to work with here. And I believe this wire, yeah, this wire is just the jumper that goes straight across to the other guy. So I'm going to, this will be hard to show with the camera, but basically I'm going to get in there, desolder this resistor, and then put it back into place on this last remaining one. Get that ready to go. Get the jumper cable ready. Yeah, resolder our cables as best as I can, and then insert from the other side. If that looks like it's not going to work, I'll get around from the other side and desolder those diodes and just do it that way. That seemed to work okay going from the back side. I actually ended up having to solder this brown wire. So basically got this one in place, this resistor, removed this red wire from the other side, soldered this resistor here and the red wire to this capacitor, put that in place, got this guy in place, soldered the red wire back over here as well as this red wire, and then this brown wire I had to get in place with pliers coming from either side, and then was able to get my soldering iron through this gap between the two diodes. It seemed to work just fine. So I think the last thing we're going to be able to do on this video is going to go ahead and replace the bias cap here. Again, we may end up modifying the bias circuit depending on what things are looking like once everything else is installed. I'll check the bias and see where it's at with no tubes, and then also with tubes, and just see if that's even going to be necessary. But if not, we'll still go over the circuit for that. I know some people are curious. And then I'll probably have to save the rest for the next video, but let's go ahead and do that bias cap and then we'll go from there. One thing to note here is the original bias cap is a 100 microfarad at 63 volts. Now, this is pretty common in older amps that they rated the bias cap at something like 63 volts, and then the bias will get up to, say, negative 50 volts or 40 volts, somewhere in that range. So it's kind of cutting it a little close. So typically install 100 volt caps whenever I'm doing this, whether it's a Fender or, you know, something like this. But you can always go up on the voltage. The only thing that'll change is the package size, usually, if at all. The microfarads, the capacitance, is what is necessary to stay the same without having any kind of tonal or frequency characteristics. So I'll go ahead and install this, being aware that our positive is going to go to this leg, negative on the other side. You can see there's a plus mark here, and there's also a black line, so those are both good indicators for the orientation there. And then we'll take a look at what that looks like installed. Okay, so we got the bias cap installed. That's going to be it for this video. On the next one, we will either go ahead and install the new transformer or go through, do the master volume, and check for any Other changes like those power resistors that were here that I removed to get to this space, or just go through and fix anything else that is out of place. Once those are installed, then we will do a power up. I'll do that on camera so you guys can see how I do that and address any issues that may come up from that. There may be other stuff that I didn't catch, or there may be things that need to go. Oh, also these sockets for the power tubes. Might roll the dice and just power up and see how those do, but they look a little toasty, and I think I have some nice ones on hand. So if that's the case, we'll go on and do those as well. Thanks for watching, as always, and we'll be back soon with the next part of the actual repair on this amp. Have a good night.